shared that one for April. We have shared the one for April. So I'll just start with this one for April. So maybe may not go through all of it, but we'll just go through, and you will see that majority of the items, some of them majority already we have looked at them. So the first one was the acronym. The CRISP stand for what? Yeah, is it cross-industry standard process for data mining, cross-industry statistical process for data mining, cross-industry standard practice for data mining, or cross-industry statistical package for data mining? So remember the CRISP framework already we have looked at it now and again, and we said that it is a cross-industry standard process for data mining. That one already even we have looked at it in the other one, in the other paper for August. Yeah, so the cross-industry. So it is good to know in full, and you can see that one they are testing. We are given the following formulas for computing variance and standard deviation over population and sample. Again, this is something that already we have explained in the previous question. So variance for S, remember S we have said is for sample, variance for P, this one is for population, STDEV, standard deviation, P is for population, and STDEV is for sample, So which one of the following statement is correct? Statement 1 and 3 contains a formula for variance and standard deviation of a population. So 1 and 3. So it contains variance and standard deviation for population. That is wrong, because the first one is variance for sample, and the third one is a standard deviation of population. So variance and standard deviation of a population. So the first one is the one that makes it wrong. Yeah, the first one is the one that makes it wrong. So we shall just have cover for 10 minutes. Yeah, after 10 minutes, mahali tutakuwa tumefika, that's where we shall stop. Then the second one, statement 2 and 4 contains a formula for variance and standard deviation of a sample. So statement 2, remember this is variance for population, and 4 standard deviation of sample. So partly is correct, but the first part is wrong for variance. Statement 1 and 4 contains formula for variance and standard deviation of a sample. So 1 and 4, yeah, this one is for sample, and 4 standard deviation of sample. That one is correct. Yeah, 1 formula for variance and 4 standard deviation of a sample. Yeah, both of them. So variance for sample, standard deviation of sample. So C is correct. C is correct in this case. Standard deviation of a sample, variance of sample. Number 3. Which one of the following focus on the discovery of previously unknown properties on the data? So previously unknown properties, yeah, the properties that already we don't know, the previously. And we said the process, when you talk about we need to discover previously unknown property, we shall be dealing with what? Data mining. So we shall mine the data, yeah, so that we know. So remember, data mining is whereby we are accessing now the raw data that we are yet to process and we are yet to analyze. So that data, we don't know the properties, we don't know the size, we don't know the velocity, we don't know everything yeah, about the data, and that is data mining, the process of coming up with new data, yeah, from different sources. Yeah, big data, we said that one already, we have looked at it. Data wrangling, that one is not. And data archiving, archiving, remember we said, is a storage of the data that we are yet to use, or the data that we no longer need to use, the data that we no longer need to use. That is what we were calling archiving. But when you talk about the data wrangling, yeah, so wrangling is a process of converting raw data into usable form. So here is just converting raw data into usable form. But remember, data mining is the process of accessing the raw data, the data that we have not yet used, that is mining. But wrangling is just that process of converting now data that is raw into a usable form. But here we need that data that we don't know, or their known properties. The fourth one, a data analyst will like to determine the number of times revenues have exceeded 10 million over the past 10 years. Yeah, has exceeded 10 million over the past 10 years. If the revenues are listed vertically in column A, that is from cell A to to cell A11 of Excel, which of the following formulas will provide the correct output? So remember, here we need to count, because here is the number of times. The number of times is counting. You just need to get the number of times. Yeah, and number of times you normally use count if. So the argument count if for all of them is correct. Count if is okay. But now we need to count from cell what? A2 to A11. So we normally start with the cells A2 to A11, A2 to A11, A2 to A11. So that means C and D, they are wrong. Yeah, C and D already we have eliminated them, because here is A2 to J11 and here is greater. So we need to calculate from A2 to A11. That's what we need to count, and we need to count that it is greater than 10 million. We normally start with the argumentation for the cell, then we go to the second argumentation. We need what? Exceeding these. So we normally open the quotes, this one, and we need greater than 10, and we close the quotes. So the correct answer in this case will be B. Count if A2 to A11, you put a comma, open the quotes, is greater than 10, and you close the quotes. So here is not equals to, that's why we are eliminating A. Remember, we need exceeding 10 million, not equals to 10 million, exceeding 10 million, and therefore we shall go with B. We shall go with B, the one that exceeds 10 million. So question number 5, Alteryx is an example of. So remember, we looked at our notes, yeah, and it was wrongly placed in our notes. So we have data management tool, data cleansing tool, data visualization tool, and data analysis tool. In our notes, you'll find that Alteryx is included under the data cleaning tools, but Alteryx most of the time, let me just read. Yeah, when you read from the notes, let me just share that. I think that's what you are having. And the tools, yeah, the tools, and it is the first tool that is under data cleaning, but it's not a cleaning tool, because they are saying Alteryx is a software company that provides a platform for data preparation, blending, and analysis. So it's all-in-one. So we are preparing, blending, and we are analyzing the data. The platform is designed to help users prepare and analyze data using drag and drop interface without requiring any coding. Alteryx platform allows users to connect to various data sources, including database, cloud application, and spreadsheets. That is what it is, and therefore, because of that, it means Alteryx is not mainly for data cleaning, but it's a data management tool. All that process that you're talking about, it falls under the data management. It falls under the data management. Falls under the data management. Under the data management, but not under the data cleaning. So mostly it's not just a cleaning, and in our notes it's wrongly placed under data cleaning. But remember, cleaning, we said, is a process whereby we are eliminating the duplicates. We are eliminating those items that are incomplete. Yeah. The one that are inconsistency, that is the main thing under the cleaning. And Alteryx, we are saying, is we can be able now to add, we can be able to access, we can be able to prepare. All those things, they fall under data management. So we are able to manage. Remember, data management, we said, is whereby we can be able to update, we can be able to store, we can be able to access under the data management. Under data management. So it's a data management tool instead of data cleaning tool. And question number 6. Question number 6, which of the following approaches to data collection will require significant data cleansing? Yeah, remember, data cleansing is whereby we are cleaning. We are cleaning that particular data. So do we deal with online administered questionnaire, email administered questionnaire, physically administered questionnaire, and all of the above? So which one will require significant? The keyword here is significant data cleaning. All of them will require data cleaning at one particular point, but which one will require significant data cleansing? And most of the time you'll find that the one that will require significant data cleaning is the one for physical administered questionnaire. Yeah, the one that we are administering physically. Yeah, the people may fill their own things. Yeah, because maybe they don't want to fill the information, or maybe they lack the know-how. But remember, for online, those people that will be accessing information online, online questionnaire are more structured. Yeah, they are more structured, and most of the time you will find that they will have less errors. Even the email, less errors, but the physical one, they will have a lot of errors, and others even people may not be able to return them. Other people will only fill it for the sake of yeah. Which one of the following function can be used to find data with unique codes arranged in the top row of the data set in MS Excel? So do we use the match, do we use the H lookup, do we use the V lookup, or do we use the setup? Be used to find data with unique codes arranged in the topmost row. So here was the topmost row of the data set in MS Excel. So we had match was looking for exact match in different columns or in different rows. So the answer here was H lookup. H is for horizontal, and we know horizontal, they are the rows. Yeah, the rows. But V in the lookup is a vertical. These are the columns. Vertical will return for the column, but H will return for the row, the one that is arranged on top most row. So the answer in the previous we were talking about V, but the answer we corrected should be H. H lookup was the answer for question number 7. So now we continue. That's where we stopped at in the previous lesson. So today we are continuing now from question number 8. And question number 8, it says that which of the following reason will make an organization avoid cloud computing as a means of data management? So remember, when you talk about cloud computing, this is where an organization stores or manages its data through internet. We store our data virtually. Yeah, we store our data virtually. The data is stored virtually, and that's what we refer as cloud computing. We don't store the data in a physical location or physical storage devices like the hard disk and others, but here now we are storing it in the cloud, and that is through what we call the internet, through the internet. Yeah, so it is virtual. Yeah, virtual, where we store our data virtually. We can be able to manage it virtually, we can be able to access it virtually, and that is a cloud computing. So which of the following will make an organization avoid? So is it data cost, data scalability, data integrity, or data safety? So remember, when you talk about the avoiding, we are looking at all of them are factors that will affect cloud computing. All of them will affect cloud computing, but when you look at the data cost, we normally say initially it is cheaper. Initially, if you don't have a lot of data to store, then it will be cheaper for you to store in the cloud. But as the data is growing, it can become expensive in the long run. That means for data cost is something that you can be able to manage. Data scalability, cloud has very big storage space, unlike these other physical location or physical storage. So for the cloud, we can be able to expand. Yeah, so data scalability, it can be able to accommodate a lot of data. So that one is not a problem. Data integrity is whether we can trust the cloud where we have stored our data virtually, whether we can trust that the data that we store there, they cannot be manipulated. Yeah, they will still remain to be accurate without any errors. So for data integrity, that one is manageable. Again, we can easily manage the integrity of our data. But when it comes to data safety, that is something that now will make people to avoid, because no matter how secure you have secured your data, you may find that still hackers can be able to crack. And still you can be able to lose your data. And we know government spends a lot of money in making sure they are storing or they are securing the data that they have, stored either physically or either through cloud. But security and safety is something that will make people to avoid, because you cannot be able to say that 100% you have managed the safety of your information or the safety of your data, and that is a major reason that will cause people to avoid storing their data using the cloud computing. But these others, you're saying still they are factors, but they are manageable. Yeah, they are manageable to some extent. They are manageable, and therefore they are not of that big concern to an organization. Then the other question, number 9, correlation analysis is an example of, so we are looking at the correlation analysis is an example of, is it predictive analysis, is it prescriptive analysis, is it descriptive analysis, or is it exploratory analysis? So remember, there is a difference between correlation and regression. When it comes to regression analysis, so you can use regression to predict. Regression is normally a predictive analysis because we are able to predict the figures or the outcome that will happen in the future. So for regression, it is predictive. But when you look at the correlation, we are dealing with the data that we have, the data that has already occurred in the past. Either it's the past or the current data. We need just to establish the relationship between the variables. Yeah, the relationship between the variables, whether they are perfectly correlated negatively or there is no correlation. That means already the data is there. We are not predicting, we are not prescribing, and therefore for correlation is normally under the descriptive analysis, because the data already we have it. Yeah, the data that we are using is the past data that we are finding the correlation between it. But for, if they ask the question the other way around, they ask about the regression will be the predictive, because that one will be used to predict any value in the future, Number 10, the following are the main examples of data visualization, and here we have 4 of them. Remember, in total there are normally 5, even the trend. We have the comparison, the composition, the relationship, and the distribution. You can remember the previous question we had the same, I think it was in question number 19, the one for August. Yeah, the one for August. So comparison, composition, relationship, and distribution. Which one of the following summarizes the order of examples from simple to complex? From simple to complex. Yeah, so the order where we are starting from simple and to complex, and we'll find that these answers and the previous answers, you'll find that they are not matching the way they are putting them. I don't know the reason why they are putting them that way, but you'll find that the previous in the previous question, and you will refer to your paper that you had for the previous, we said that we were starting with the trend, but here we don't have the trend. Then we were going to comparison. Yeah, just a reference to what we had done, comparison. Then the other one, after comparison, we were going to distribution. Then we were going to the other one we are calling relationship and composition. That is under the previous question for August, the one that we did for August. But you'll find that for this one now, because of the way it is arranged, composition, not composition, comparison should be the least, whereby the simple one where we are comparing using the charts. Yeah, comparison is said is where we are using the charts, the bar charts. Composition is where we are using the pie charts. Yeah, composition, the pie charts. The distribution one is the line. Yeah, line chart still comes in, and the bubble chart still comes in the distribution, and the relationship now, the histogram and the rest can be able to apply under the relationship. So for this question, because we don't have the trend and they have interchanged, you'll find that they have interchanged the composition and distribution compared to the previous question that we did. And but because of that, still, even if they have interchanged the composition and distribution, still C remains to be the one with the one from the simplest to the complex. Comparison, the bar charts, each and every person can be able to create a bar chart because that is a simple. Composition, the pie charts are the other easy that are used normally. The distribution, the lines, because the time graphs and the line graphs, they are rarely used, the scatter graphs. Then the relationships for the histograms, and sometimes still the line graphs still appear under the relationship to show relationship between one or more variables, and under the relationship still even bubble circles still appear under the relationship. So for this question we shall go with the C, comparison, composition, distribution, and relationship. Then number 11, question number 11, yeah, that was question number 10. Number 11, one or more of the following activity is or is are not from phase 1 of data science life cycle. Data science life cycle, you can remember what we are looking at, the life cycle, data life cycle. So we have learning, the target domain, then developing initial hypothesis, then visualizing the initial hypothesis, and then all of the above. They just need one or more of the following activity and not from the phase 1 of data science life cycle. So from the phase 1, remember the phases, there were 6 phases. Yeah, there were 6 phases that we were looking at in the previous. I'll just take you briefly under the phases, just a little bit under the phases, so that you can just have the right thing. Under the phases, yeah, remember we had stages and the phases, the V's, yeah, those are, yeah, here, almost there. Yeah, this one. So these are the stages, and under the stages we had the phases here. The data life cycle typically involves the following phases. So phase 1, where we were dealing with the data acquisition, and under data acquisition, here we were dealing with, this is the phase where data is gathered from various sources and prepared for analysis. So we gather data from various sources and we prepare it for analysis. The first step in this phase is identifying the relevant data sources, which involves determining which sources are most appropriate for analysis. That is under the first phase, data acquisition. Phase 2, you are dealing with the data preparation. Phase 3, you are dealing with the data analysis. Phase 4, you are dealing with the data visualization. So visualization was coming as the 4th, and the 5th one was data storage and management. Data storage and management was coming as the 5th. So in our case now, they are telling us, in our case, yeah, I'm back to question number 11. Which one of the following activities is or are not from phase 1 of data science life cycle? So learning the target domain, yeah, where we are collecting the data, developing the initial hypothesis. So remember, the hypothesis is the objectives. When we are collecting the data, we are learning, or we are trying to collect the data that will assist us to answer some specific questions, and that's why we are developing the initial hypothesis under this one. But when you look at the visualize initial hypothesis, here we are not visualizing. Visualization, you have seen it comes as phase 4 for data visualization. So visualization doesn't happen in phase 1, but we are learning the target domain. The target domain is the data, the initial data that we are gathering. So we are learning that data that we are gathering, we are preparing it, because that one is under the first, still under the very first phase that we are having under data acquisition. Here where we are gathering data from various sources and we are identifying the relevant data. That's where we are learning our target domain or our targeted data. But the only activity that doesn't happen is visualizing the initial hypothesis. So visualization is not under the phase 1 but under phase 4, and that's why that one will be our answer, part C, visualization of the initial hypothesis. Then question number 12. So the following statements relate to the V's of big data. V's of big data. Number 1, variability is the evolving nature of data sources, and number 2, variability is the different types of data structure. Which one of the following statement is correct? Which one of the following statement is correct? So the first one is variability is evolving nature of data, and variability is the different types of data structure. So only statement 1 is correct, statement 2 is correct, both statements are correct, both statements are wrong. You can remember we looked at the 5 V's, and here we are looking at the variability. Variability is under the way the data is structured, different types of data structure. So it's about the different types of data structure, but not the evolving data, not the evolving nature of data sources. So our correct answer when you talk about the variability is statement number 2. And all these you can be able to refer them because we had covered them in our notes. So only statement 2 is correct. Different types of data structure. In question number 13, so the following is considered by many to be the most important language for data science. The most important language for data science. So do we deal with Ruby? Do we deal with R? Do we deal with Java? Do we deal with MS Excel? Yeah, so this one for data science, which is the most important? Which is the most important? The most important. So is it Ruby? Is it R? Is it Java? Or the others? Yeah, and you'll find that when we are dealing specifically with data science, data science is whereby we need to analyze the data, we need to extract, deal with data mining and so on. So MS Excel cannot be used, and even Java. Java normally is for programming, coming up with a programming language, because Java is a programming language. But when it comes to R, R is normally used by data miners, data miners and other statisticians for data analysis and developing statistical software. So it is for data analysis, and again it can be used to develop statistical software, not only analyzing but even to develop. So remember, Java is developing all other softwares, and especially the mobile phones applications. Some of them, they do use the Java programming language to develop those applications. But the R, most of the scientists, they normally use the R in order to come up with data analysis softwares, and also to analyze the data, because it's a programming language that is used to do the analysis and also to do or to deal with data mining. So it's normally the core language that is normally used by many data scientists. So when you hear about data scientists and the language that is being used, there we are talking about the R. We are talking about the R language. Next 13, number 14. So 13 is B, is our answer there. Number 14, which one of the following choices best represents the correct flow of data models? Correct flow, I think we looked at that. Conceptual, logical, physical, logical, conceptual, logical, then physical and conceptual, none of the above. So you find that the data models, we said the first thing we start with the conceptual. Conceptual is a basic, and this one we said the key thing under the conceptual is a high level analysis for showing the relationship, and normally it is used by those people that are not experts. Those people that are not experts in development of databases, and so on. So it's not for the users that are well versed, but those that are just common users, and that's why it's for beginners to understand just the relationship, how the variables will be related, how the entities will be related. That is under the conceptual. Logical, now we said we are going to a step further, and we look now at the entities and the relationship in detail, how they will be related and how these entities will deal with one another. That relationship, deeper relationship. And under the logical, we said it forms the basis. Logical forms the basis of creating the physical database. Now the physical database, and it's normally used by the database administrators, database administrators, and those people that now have the wider knowledge about coming up with the database, those ones will apply it. The physical, we said we deal with either the storage, how the database will be stored, and the technology of accessing, how the data will be accessed. Which particular technology shall we use to access the database? And again, we said under the physical is whereby we deal with the database implementation, how we shall be able to implement our physical database under the physical data model. So the correct flow starts from conceptual, logical, and then physical. Conceptual, logical, then physical. Then question number 15. Number 15, choose the correct keyword for this definition: a graphical representation of a data set. So the keyword is graphical here. Graphical representation of data set. And so you cannot use graphical representation. Again, you repeat the word data set. Investigative cycle, visualization, data plot. Remember, graphical representation, we said that one is data visualization. Yeah, we had said about the visualization. There we deal with the visualization of data. Data plot is just but plotting now the data that we had, but it's not the graphical representation of data set. But here when you talk about visualization, that is the key term. All the data that we have now, we visualize them using the graphs. Yeah, and we say the key reason we are visualizing it so that the end user can be able to understand it in a better way and to have a better and easy way to interpret that particular data set. Then this one should be question number 16. Yeah, I think they had an error of writing. Question number 16. The dash data model gives the data analyst the chance to gain an overview of the system to be analyzed without being concerned with the details of how it will be analyzed. Again, another question of data models. So remember here, gives the data analyst the chance to gain an overview. It's just but an overview of the system to be analyzed without being concerned with the details of how it will be analyzed. So here we are not going into the detail, and we said if we are not going into the detail, we are dealing with the conceptual. We are dealing with the conceptual. Conceptual doesn't go into detail. Logical is the one that goes into detail over how the system will be analyzed, and the details, the much details, will go to the logical. Physical now is about the implementation, because already we have known how the system will be communicating to one another, the entities, we know all those items under the logical. Physical is only to implement the database, where we shall be able to store it, how we shall be able to access that particular database. That is under the physical. Rational is not there under that particular case. So that means the one that will show us and give us give the analyst a chance to gain just the overview is the conceptual. Then number 17. Number 17. Bank collected data on visitors' viewing habits at the bank's website. Which technique can be best used to identify pages commonly viewed during the same visit to the website? Yeah, so they need us to identify which technique can be best used to identify pages commonly viewed. Yeah, pages commonly viewed during the same visit to the website. So these are bank customers, and they are visiting the website of the bank, and we need to analyze and be able to know which pages are commonly viewed. So do we use clustering? Do we use classification? Do we use association rule? Do we use panel analyst? Which one shall we be able to use? So we can just explain one by one briefly. When we talk about clustering, it's normally a task of grouping a set of objects in such a way that the objects in the same group are more similar to each other than those in other group. So this one is just but classifying objects from one particular group to another. Yeah, just grouping them so that they are more similar in the same sense. That's what we are calling about clustering. Classification, we know where we are classifying similar data. Yeah, we are classifying similar data either according to anything that we are dealing with. That is the classification. And normally under data mining, we normally talk about classification is a common technique that separates data point into different classes. So we are separating data points into different classes. That is the classification. When you talk about association rules, that is where items are associated with one another. Yeah, that is where items are associated. Association in mining functions finds item in your data that frequently occur together in the same transaction. So remember, that is association. That's why now we are using the word rules. Yeah, association in mining function finds items in your data that frequently occur. Remember, here we are identifying pages commonly viewed during the same visit, and that is association where we are finding items in your data set that are frequently occurring together in the same transaction, and therefore that one seems to be our answer. But we shall look at the other one again. Yeah, and again, the other thing, we normally talk about association rules as a basic level involved in the use of machine learning models to analyze data for patterns or co-occurrences in the databases. Co-occurrences that are happening almost at the same time. Co-occurrences at almost at the same time. Then when we talk about the panel analysis, that one is a statistical method widely used in social science. Social sciences, and normally it is to analyze two-dimensional panel data. So the data that are two-dimensional, that is where we are dealing with the panel analysis, and therefore the data or the method or the technique that will be able to identify these or visitors of the bank that are visiting the bank's website, we shall use the association rules. Because we are looking at the co-occurrence or the number of times items are being repeated. And the next one, number 18. The following statements apply to data mining. So we have predictive. Data mining is a type of data analysis that extracts data that may be helpful in determining an outcome. So remember that one is predictive under this one. Descriptive data mining is a type of data analysis that informs users of the data of a given outcome. So I will repeat. Predictive data mining is a type of analysis that extracts data that may be helpful in determining an outcome. The data that may be helpful in determining an outcome. And descriptive data mining is a type of analysis that informs users of data of a given outcome. So the question, which of the following is correct? Do we deal with the only statement 1, only statement 2, both 1 and 2, or both statements? And we'll find that here, when we talk about predictive data mining, is a type of analysis that extracts data that may be helpful in determining an outcome. So remember, predictive, we are looking at futuristic. Predictive, we said, is futuristic. So we are extracting data that may be helpful in determining an outcome. The outcome is yet to occur, and that's why we are talking about predictive. We are predicting something that will occur in the future. Descriptive, we said, is past, present and past. Descriptive data mining is a type of data analysis that informs users of the data of a given outcome. So we are informs users of, so descriptive data mining is a type of analysis that informs users of that data of a given outcome. So remember, here we are talking about a given outcome again. So given outcome is outcome that is yet to occur. But remember, descriptive, we are saying, is in the past. It is not either past or present, but already for descriptive, already the events have occurred. And that's what we are analyzing, because already they have occurred, and when we analyze them, they will help us to predict the future. So descriptive does not deal with outcomes. Given outcome, already the outcomes have occurred, and that's why now for this case we shall only deal with predictive data mining, which they extract data that may be helpful in determining an outcome. Therefore it will be only statement 1 that will be true, but for the second statement is not true, because we are talking about outcome, and description, we are describing the data in the past and in the present. Already the data has occurred, already the data is conclusive. In question 19, which of the following steps is performed by a data scientist after collecting the data? So already we have collected the data. So do we deal with data integration, data replication, data cleansing, data manipulation? So the first thing that the data scientist will do after collecting the data that has been collected, the data needs to be cleansed. Data cleansing or data cleaning, to remove errors, to remove duplicates, to remove incomplete, or to deal with those data that are incomplete. So the first thing, before you use that particular data, and we had mentioned that you need to do with data cleansing. You need to deal with data cleansing. So you're not manipulating the data first, you're first cleaning the data. You're not integrating it with any other data. First you clean that data so that you're preparing. The process of, or the reason we are cleaning, is in order to prepare that data to be used in model. Before we do data modeling, first we are cleaning the data to be sure that the data is it will be helpful to deal with the other, or to be used in other areas, And the last one, question 20, which of the following best describes the work of data architect? So architecture is like the one for the house. Architect, yeah, utilizing large set of data to gather information that meets their company needs, work with business to determine the best usage of the information yielded from the data, develop data solutions that are optimized for performance and design application, and evaluate data to reach at logical conclusion. So the work of an architect in anything, either is a house or even in data mining and data science, the work is to develop data solutions that are optimized for performance and design application. So developing data solutions, yeah, coming up with those solutions, packages that we are talking about, the softwares that we are talking about, that will be the work of an architect, coming up with those data solutions. So he's not utilizing any data, he's not working with the businesses to determine the best usage. No, he is being used or being utilized to design, either design application or development. In the development phase, coming up with those softwares, coming up with those programs, that is where the data architect work lies. And that is all under that particular paper, and those are the paper that we have covered for theory. Remember, theory is just 20 questions, each question carrying 1 mark, and the other two papers we may not go through them. The one for December 2022 and the other one was for September. Yeah, the September 20, is it September or the pilot one? Yeah, the pilot one, you'll find that in the notes that we have already. That one has been dealt with. Yeah, in the book that we have, just a brief. So that one will go through it unless we'll be having any clarification, but the two papers already, they have been tackled, the one for September and the one for December, and they have explained, yeah, they have explained in detail. Yeah, so you'll find that the multiple choice revision question, you'll find the one for pilot, yeah, the pilot paper for 2022, and after this one you will find the one for December. Yeah, even December they have covered it here. They have covered the December one. So when you're done with these, yeah, the December one, yeah, this one, multiple choice revision question for December 2022, even this one here is covered. So you'll go through this one because already you have the answers, unless where you will feel you need any clarification. That is where I will come in, so that I give you now ample time to refresh on the areas that we have covered and to relax the mind, because I believe we have covered extensively. And we believe that everything will be possible